So the second problem that I gave my students last semester dealt with actually finding limits algebraically. So for the next example, we have 3 limits. We want to find the limit if it exists and then give its value. If it does not exist, we will state why. So for the very first one, we have the limit as x goes to 4 of x squared minus 8 over x minus 3. Now, anytime you have a limit, you want to just try to plug in the value to begin with. Because as we learned, if you plug in the value and nothing bad happens, then the limit is the value you get. So we're going to get the limit as x goes to 4 of x squared minus 8 over x minus 3. Well, if I plug in 4, that would be 4 squared minus 8 over 4 minus 3. 4 squared is 16. 16 minus 8 is 8. And 4 minus 3 is 1. Nothing bad happened here. So let's go ahead and simplify. 8 over 1 is just 8. And that would be our answer. Now that's rather boring, so hopefully the next one will be a bit more exciting. So let's start. Let's actually plug in the value -1 for x. We're going to get -1 squared minus 1 over 3 times -1 squared plus -1 minus 2. Now in the numerator, if I square -1, I'll get a +1, and +1 minus 1 is 0. In the denominator, when I simplify, I'll have 3 times 1 minus 1 minus 2, which is also 0. And very importantly, we learned that this is called indeterminate. We also learned that indeterminate typically means the limit does exist. We just can't figure it out the way that the function is written. So something that you can do with limits that you cannot do with functions is you are allowed to factor and simplify if possible. Now we see that in the numerator we have x squared minus 1. You should notice that this is the difference of squares, and we'll factor into x minus 1 times x plus 1. In the denominator, we have what's called a trinomial, 3x squared plus x minus 2. Now there are many different ways that you can factor a trinomial. Often I see students using the AC method, or just by doing some mental trial and error math. We can factor this one into 3x, let's see, minus 2 and an x plus 1. And now we see something exciting occur. We have a factor in the numerator that is the same as a factor in the denominator. So they can cancel, leaving us with the limit as x goes to -1 of x minus 1 over 3x minus 2. So let's plug in -1 now and see what happens. We'll get -1 minus 1 over 3 times -1 minus 2. In the numerator, 1 minus 1 is -2. Sorry, -1 minus 1 is -2. And 3 times -1 minus 2 is -5. If we simplify, we will end up with positive 2/5 for our final limit. Okay, we have one more limit that we want to do. Now, this limit is important to be careful with because it's a limit at infinity. Now, if you can imagine, this is somewhat hypothetical, but if we plugged in infinity, what would happen? Well, in the numerator, we'd have infinity squared. That's ridiculously large. It's roughly infinity. And in the denominator, we have 3 times infinity squared. Well, that's also roughly infinity. And infinity over infinity is another value that is indeterminate. Ooh, if I could spell the word right. Okay, indeterminate. So what do we do when this occurs? Well, there's a different rule that we use for limits at infinity. We divide every single term by the highest power of x in the denominator. So the highest power of x in the denominator is x squared. And I'm going to divide every term by that. So I'll have x squared over x squared minus 4x over x squared minus 1 over x squared. And that's all divided by 3x squared over x squared plus 7 over x squared. These tend to look a lot messier when you're actually trying to solve. So before we can solve, we are going to simplify. So we still have the limit. Please watch my notation in all of these problems. We haven't taken the limit yet, so we have to keep it in front of the expression. We have the limit as x goes to infinity. Now x squared over x squared, that's just 1. 4x over x squared will be minus 4 over x. And the last term cannot simplify. In the denominator, 3x squared over x squared is just 3, and 7 over x squared does not simplify. So it might seem like we're stuck here, but if you remember, we learned in the text that if we have a number divided by x to a positive power, that value will go to 0 in the limit if x is going towards positive or negative infinity. And this is important, it only works if x is going towards positive or negative infinity. Because if we look at our second term in the numerator, 4 divided by a really large number is essentially 0. 1 divided by a really large number is essentially 0. And 7 divided by a really large number is essentially 0. So what does that leave us with? Well, it leaves us with 1 over 3. So our limit would be 1/3. Okay, we have problems 3 and maybe even 4 coming up next.